Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the Rolle's theorem and the mean value theorem. So first of all, we will see the definition of the Rolle's theorem. So let f be the function that satisfies the three hypotheses, three conditions. So what are the three conditions? F is continuous on the closed interval. So the interval is closed a comma b, and f is differentiable on the open interval a b. Then so we will have f of a equal f of b. These three conditions. Then, if it is satisfied, then there exists a number C such that it will lies in between A and B. So you will find it, the C will be within A and B. So this is the Rolle's theorem says. Now similarly, the mean value theorem is the same rule. The two conditions are going to be the same. What is the only change? So f is continuous on the closed interval, f is differentiable on the open interval, everything is right. Now there exists number C, but instead of 0, the condition, how to find the after critical region. So how will you find the C? By putting just 0 in the Rolle's theorem, but here we will put it f of b minus f of a over b minus a. Or you can just cross multiply, you will get this equivalent part. So here also this value, the a c value must be in between a and b. So let us check. So how will you find this one? Before going to this one, so as we know before, the continuity function continuous, a polynomial is continuous everywhere means throughout the real line. So it is, the rational function is continuous in its own domain, it is defined, it is a domain. So all are the functions which have the different types of function: polynomial, rational, root function, and we will have a trigonometry function, inverse trigonometry, exponential, logarithm. All are continuous in their own domain. So let us start with the first problem. I have to go with this one. If the question is mentioned as a Rolle's theorem, you have to solve by using Rolle's theorem. So if it is nothing is asking, it is your choice to do. Either you can go for the Rolle's or mean value theorem. But in the question it is mentioned. So let us start with this one. First of all, the given f is a polynomial. Since f is polynomial, f is polynomial and it is continuous throughout the real line. So I will write it this part as the first condition. F is continuous in the closed interval. I just copy this one. So f is continuous on the closed interval. The first condition satisfies. F is continuous on closed interval. Closed interval a comma b. A comma b is what here? The point is -1 comma 3. This is a closed interval. And f is differentiable. F is differentiable on open interval. On open interval minus 1 comma 3. So the third one, I have to check whether f of a equal f of b. Let us start with this one. F of -1, what happened? What is f of +3? So let us start with this one. I just take the calculator and do what is the value we will find. Let us fix the function first. 2x square minus 4x plus 5. Then cal c, give the value -1, so the value will be 11. So you will get the 11 here. So what about the cal c3? Cal c3, the value is also 3. Therefore I say this is satisfies, both values is equal 11. So it is equal. So Rolle's theorem is satisfied. Now our condition is to find the value of, there is a number c in which the in between the value. How will you find? Just put it the f prime is equal 0. So I just substitute the value here. So first differentiate this part. So what is the differentiation? By Rolle's theorem. By Rolle's theorem, f prime of c is equal 0. So what is f prime? So I just differentiate. The given function is f. So I differentiate this part. What is the differentiation? You will get here. So we will have f prime. So it is 2, 4. The given function, I write it, f of x equal 2x square minus 4x plus 5. Differentiate this part. So you will have here 4x minus 4. Since I have to substitute the c value, just replace x as a c. So you will get here as 4c minus 4 is equal 0. Therefore, 4c is equal 4 and c is equal 1. So let us check. So whether this is inside the interval or outside the interval. The given interval is minus 1 to 3, which is, so this value plus 1, which is lies inside. Therefore, Rolle's theorem is verified. So therefore, I say here, Rolle's theorem satisfies or verified. If it is outside, we say it is not satisfied, is not verified. So it should be inside the given interval. So this is what we have. Now let us start with the mean value theorem. In the question, verify the three axioms of the mean value theorem and then find the value C that satisfies the conclusion of mean value theorem. So it is a cubic equation here. So I write it, since the given function f of x is a polynomial. This is a polynomial. So f of x is polynomial and it is continuous on all the real line. So I write it this one. The first condition is true. So f of x is continuous on closed interval. Closed interval. What is the interval? Minus 2 comma 2. And number 2, f of x is differentiable on open interval minus 2 comma 2. So this is a minus 2 comma 2. And we will have number 3 is the condition I have to prove that f prime of c is equal f of b minus f of a over b minus a. For that one, I have to find it all this value. But in the Rolle's theorem, just we put it equal 0 simply. This is a particular, the Rolle's theorem, by the way, it is a particular, the special case of the mean value theorem. Just put it 0. But here we have to satisfy all the things. So for that one, I just fix the function first. What is the function you have? It is x to the power 3. X to the power 3 minus 2x square minus 4x plus 2. Then we will put this value f of a and f of b. What is f of b minus 2? By the way, this is the a and this is b. So f of minus 2. So what is f of minus 2? So I just put it minus 2. So the value will be minus 6. And I substitute what is f of 2. What is f of 2? Cal C. Use the value 2. So again minus 6. Okay. So these are the values you have. Now I just put it there. By Rolle's theorem, find the f prime. What is the f prime? So f prime is given by, take the function and differentiate. So it is 3x power 2 minus 4x minus 4. So I have to substitute the c value here. Therefore, f prime of c is equal 3c square minus 4c minus 4. And then we will have, I just substitute the value here. So f prime is 3c square minus 4c minus 4 is equal. What about the f of 2? So in place of this one, I just replace this in terms of the given interval. So this is, I write it f of 2, the b f of minus 2 over 2 minus of minus, it become plus 2. So here, so what is the value here? Find it. So this part you will find it here. The 2 is minus 6. Minus of minus, it become plus 6 over 4. Since the 0 over 4, this value will be 0. So we will get the value on the right hand side is 0. So this is 0. So this part is, the entire part is 0. And here we will get it. So the entire part is 0. And we will have the f prime here. So now solve. How will you solve this one? Again calculator. I will use the calculator to solve the quadratic equation. Here mod, see, mod 5. This is 3. What is the coefficient? 3 equal minus 4 equal minus 4 again. So therefore equal again. So you will get c is equal to, again we will have 2c value because it's a quadratic. It is minus 2 over 3. If you write it in decimal, what should be the decimal? This is minus 0.666. Okay. So let us check here. So what happened? The given interval is minus 2 to plus 2, since it is open, differentiable open interval. So therefore 2 is not included. 2 is not included. So this is not included. But this minus 0.66, it will be here. So it will be inside. So C value is equal minus 2 over 3, which is lies inside the C. So therefore it belongs to minus 2 over plus 2. So this is the thing, and I will write it here. The mean value theorem satisfies. The mean value theorem satisfies. The mean value theorem is satisfies at c equal 3 minus 2 over 3. So this is what you will have, the two equations. Similarly, for all the problems, same rule we will apply for the all the problems. Now the next problem is a special problem. Why? Because here it is show that the equation has at most one solution in the given interval. What is the meaning of at most? What is the meaning of at most one solution? It means that either you will have zero solution, no solution, or you will have maximum one solution. That is the meaning of at most one solution. You have a no solution or one solution. So this is meaning of at most one solution. So I will solve this by Rolle's theorem because it's easy. So f of x, given function f of x is x power 3 minus 15x plus c. Okay. Now I will say it's a polynomial. Whatever be the constant, it is not affecting the polynomial. Therefore, f of x is continuous on the closed interval, minus 2 comma 2, and this is the number one. Number two, f of x is differentiable on the open interval minus 2 comma plus 2. Okay. Number three, I have to check here f of minus 2 and f of plus 2. What is f of minus 2? If I substitute minus 2, it become minus 8. Here, if I substitute minus 2, it become plus 30 plus c. So which in turn implies 22 plus c. Whereas here, if I substitute 8 minus, which is equal here 30 plus c, which is equal minus 22 plus c. Therefore, we say here f of minus 2 is not equal f of plus 2. So here the Rolle's theorem is not satisfied, failed. Let us continue this one. What happened if the critical value? So what is the critical value here? So 3x square minus 15 x become 1, the c becomes 0. Now if you solve this part, f of c is equal 0. So 3c square minus 15 equals 0 by the Rolle's theorem. This part is the condition of the Rolle's theorem. Then we will have here, so c square is equal 5. Move 15 here over 3, which is 5. Now square root you will get plus or minus. You will get plus or minus root 5. So what is the value of root 5? Let us check the value of root 5 here. So root 5. So answer will be, in decimal I need 2.236. I write it here. So you will get 2.236 plus or minus. So you will get this value. Now the given interval. What is the given interval? The given interval is minus 2 to plus 2. But what happened this part? What happened this part? It is minus 2 point. It's more than. So you will get 2 point, minus 2.236 is outside the range on the left side, and similarly here also it is outside the range in the right side. So therefore it is not inside the interval. So we can say if the Rolle's theorem is not satisfied, it has no solution. So two solutions are outside the given interval. So I write it here. F of x has at most, hence f of x has at most one solution in the interval minus 2 comma 2. So you can see, view the PDF file in the description box. Thank you.